Evening, class 9. Light continue. Question number 2C. Remaining questions of yesterday. Find the angle of incidence I. Here, since the ray is bent towards the normal, it means it is passing from rarer medium to a denser medium. This is not the angle of refraction. This is the angle of refraction R. So, here angle of incidence what? Angle of refraction 90 minus 60, 30 degree. The refractive index is 1.5. Since the light is passing from rarer medium to a denser medium, we know mu equal sin I by sin R, because the light is passing from rarer medium to a denser medium. 1.5 sin I unknown, sin R sin 30 degree, or sin I equal 1.5 into sin 30 degree cross multiply, or sin I equal 1.5 into half or 0.75. Then what to do? Sin I equals 0.75. Here you have to use a calculator, or I equals sin inverse 0.75. Sin inverse, because it is the value. You don't know the value. Test, degree test. Sin 30 degree is half. See, sin 30 degree half. So I need sin inverse. To get sin inverse, you have to write sin inverse 0.75 is written as shift sin 0.75 equal to. You have to write down shift, then sin, then 0.75. See, shift, then sin. It means sin inverse 0.75 equal 48.59. 48.59 degree. So the angle of incidence is 48.59 degree nearly. This is the angle of incidence. Since the ray is passing from rarer medium to a denser medium, I what? Angle of refraction is not this. 90 minus 60, 30. Refractive index given 1.5. Mu sin I by sin R 1.5. Sin I by sin 30. Cross multiply sin I 1.5 into sin 30. Sin 30 is 1 by 2 or 0.5. 0.75. I equals sin inverse 0.75 or 48.5 degree answer. This is the angle of incidence. Question number 2. The question number 2D. Question number 2D. Here I equals C. This is angle of refraction is 90 degree. Mu equal 1.76. That is the value of the angle of incidence. What you have to do? This is the critical angle. The critical angle is the angle of incidence in the denser medium, for which the corresponding angle of refraction in the rarer medium is 90 degree. Since angle of refraction R equal 90 degree, this angle of incidence is equal to the critical angle, special case of the critical angle. See what you do. I equal C, R equal 90 degree given. Refractive index mu equal 1.76 given. We know mu equal sin R by sin I from denser to rarer medium. Light is going from denser medium to a rarer medium, or refractive index is 1.76 given. Sin R sin 90 degree upon sin I. In this case, if angle of refraction is 90 degree, I equal C. I equal angle of incidence is equal to the critical angle, or sin C into 1.76 equal sin 90 is 1, or sin C equal 1 upon 1.76. Again, 1 upon 1.76, see, 1 divided by 1.76. See, here you can see 5.68. You can see this, but is it correct? No, there is minus 1. So since the calculator shows this minus 0.1, it means divide by 10. Yeah, minus 1 somebody divide by 10, 2 somebody divide by 100. So write fix 3. You have to write fix 3. Put fix 3, or sin C equals 0.568. Fix 3, or C equal sin inverse 0.568. Right? Sin inverse, shift sign. I have shown. First write shift, then write sin, then 0.568, then write equal to. How you write? See, shift sin means sin inverse 0.568 equal 34.61, or 6 C equal 34.61 degree nearly. So the angle of incidence in this case is 34.61. Here the ray is passing from denser to a rarer medium, and I equal C, R equal 90, refractive index given, formula mu equal sin R by sin I, 1.6 sin R sin 90, sin 90 is 1, cross multiply, sin 91, sin C 1 upon 1.76, calculator 5.68 minus 0.1. It means fix 3. Do fix 3, it is 0.568. It is not 5.68, it is 0.568. C equal sin inverse 0.568, 34.61 degree nearly. This is the angle of incidence, that is critical angle. For final practice of light, I'd like to give some questions. PLE model questions of unit light. PLE for standard 9. For standard 9, I'm going to write down some questions. Question number 1 is draw a neat diagram of a glass slab to show refraction of light through it. Also label it. Question number 1. You have to draw glass slab, and first of all refraction towards, bend towards and bend away. Question number 2 is draw a neat and labeled diagram of a glass prism to show dispersion of light through it. Question number 3 is write applications of X-rays and ultraviolet rays. Question number 3. Question number 4. Distinguish between A number, X-ray and ultraviolet ray. For the sake of examination, from the examination point of view, you can write 2. X-ray 10 to the power minus 11 to 10 to the power minus 8 wavelength. It is produced by the X-ray machine and it is useful to kill cancer and to study heart tissue. Ultraviolet ray, it is produced by an electric arc or by the sun, and its wavelength is 10 to the power minus 7 to 4 into 10 to the power minus 7 meter. And use of ultraviolet ray to produce visible light in fluorescent lamp, vitamin D, and some others. Question number A. Question number B is light wave and sound wave. Another also glass slab and glass prism. That question is also sometimes asked. Question number 5. Write 4 laws of refraction of light with ray diagrams. I have already written the answers. Please try yourself. Draw with ray diagrams also. You have to draw ray diagrams as well. Question number 5. Write 4 laws of refraction of light. Denser to rarer, rarer to denser. Snell's law. 1. Snell's law. Another special case. Another denser to rarer away, rarer to denser towards mu sin I by sin R. And special case, I, when a ray of light is normally incident, it is normally refracted without bending. 4 laws. And another law, the incident ray, the refracted ray, and the normal to the point of incidence all lie in the same plane. First law. Second law, if a ray is normally incident, it is normally refracted. Third law, Snell's law. The ratio of the sine of the angle of incidence to the sine of the angle of refraction for any two given media is constant. It is called the refractive index. If a ray passes from a denser medium to a rarer medium, it is bent away from the normal. If a ray passes from rarer to denser, it is bent towards the normal. Here I have already written dr away and rd towards. For smart study, you don't need to read the sentences by heart. You पुरै घोगेर पनि पर्दैन. जस्तो only technique dr away rd towards. Denser to rarer away, bent away, rarer to denser, bent towards. And mu equals sin I by sin R. Question number 5. Question number 5. Question number 6 now. Scientific reasons as well. Question number 6. State reasons. Here scientific reasons. Stars twinkle. Air has different densities, different layers. Different layers of air have different densities, which vary in small size, small range, and the relative position of stars seem to change. Therefore, a type of current is also produced, due to which stars twinkle. A fish or coin, fish inside water or coin placed inside water seems to be raised. You have to write down the answer this way: due to the refraction of light from water to air, it is bent away from the normal. Another also, a stick or pencil or glass rod dipped obliquely inside water seems to be bent. It is also due to the refraction of light from water to air. Another, a glass prism is used to disperse light, but not a glass lamp. Why? This question is somewhere in the book, but you may not know. A glass lamp, a glass prism is used for the dispersion of light, not a glass lamp. Reason, or you can write refraction. In a glass lamp, refraction occurs in the opposite direction. The glass lamp also, light also splits into 7 colors, but the 7 colors again recombine to form a white ray, but in a glass prism, it is designed in such a way, a glass prism, refraction occurs in the same direction. Refraction occurs in the same direction, and the 7 colors called B, I, B, G, Y, O, R, violet, indigo, blue, green, yellow, orange, red. 7 colors can be seen. So, a glass prism is useful for the dispersion of light, whereas a glass slab is useful for the refraction of light. Dispersion of light and refraction of light. One difference is that a glass prism is used for the dispersion of light, but a glass slab is used for the refraction of light. There is one difference. Question number 6. Six A, B, C. 6D. 6D. You can write so many other questions like light is an electromagnetic wave. The answer was already written, but I am going to write down. some. It is all maybe new to you. Light is the electromagnetic wave. Why? The reasons are as follows. Either you can write in points or light travels even through vacuum at the speed of 3 into 10 to the power 8 meter per second. One thing. Another, it obeys the laws of reflection, refraction, diffraction, and interference. Interference. Another, it increases the temperature of the particles of the medium. Temperature of the particles of the medium through which it travels or through which it is traveling. In this way, light is a thus, or in this way, light is an electromagnetic wave. Light is an electromagnetic wave. Other questions are also there. Question number 7. Define the following term. Define a refraction of light, dispersion, refraction, bending of light, dispersion, splitting of white light into 7 colors. Another, mirage. Mirage is an optical illusion due to the total internal reflection. Suppose, for example, a person walking along a road, along a very hot road in summer season, especially in the daytime, thinks that there is water in front of him or but there is no water. It is due to the evaporation of air. It is his optical illusion due to total internal reflection. D. Mirage. Critical angle. The critical angle is the angle of incidence in the denser medium for which the corresponding angle of refraction in the rarer medium is 90 degrees. We can give examples like water 49 with 3 examples. Give 3 examples. At least 3 examples. Water 49, for example, water about 49, glass about 42, and diamond about 24. They are some examples of the critical angle. D. Total internal reflection. Total internal reflection with 2 conditions. Total internal reflection with 2 conditions. Total internal reflection. It is the process or phenomenon of returning of the light towards the same denser medium after striking the surface. 2 conditions. The ray must pass from a denser medium to a rarer medium. Condition number 1. Condition number 2. Condition, the angle of incidence must be greater than the critical angle. First condition, dr, and another c. For smart study, you have to write down this for smart study. What do you mean by this? dr and ic. I is more than c. It means the ray must pass from the denser medium to a rarer medium. For condition number 1. Condition number 2, the angle of incidence must be greater than the or bigger than the critical angle. These two conditions, D and I is more than C. Denser to rarer, angle of incidence more than the critical angle. Question number 7. Question number 7. Question number 8. Question number 8. Name the device to produce the X-ray. It is X-ray machine. Here I have not written the sentence. The device used to produce X-ray is the X-ray machine. Another, name the thing or any instrument to produce ultraviolet rays. Here the sun, the electric arc or fluorescent lamp, the sun, the electric arc or the fluorescent lamp, etc. produce ultraviolet rays. Question number 9. Write some properties of electromagnetic wave. Some properties of electromagnetic wave, like light wave. You can write some properties of electromagnetic wave. They travel even through vacuum at the speed of 3 into 10 to the power 8 meters per second. They increase the temperature of the particles through which they are traveling. Another, they obey the laws of reflection, refraction, diffraction, etc. And they can be produced and they can be converted. That is also one. Question number 9. One remaining. Define the refractive index and write its formulae. It has 3 formulae. First of all, let me write down one formula. Another formula, dA by dm. Another, sin I by sin r, or for this, sin r by sin I. See, refractive index definition. It is the ratio of the real depth to the apparent depth. It is also the ratio of velocity of light in vacuum to the velocity of light in medium. Another definition. Refractive index is the ratio of the sine of the angle of incidence to the sine of the angle of refraction for any two given medium. When light travels from rarer to a denser medium. When light passes from denser to a rarer medium, mu equals sin r by sin I. Question number 10. Condition. Another, when does Snell's law fail? Or what is the condition when Snell's law fails? When I equal 90 degree, Snell's law fails or does not volt. When I equal 90 degree, then R is also 90 degree. At that condition, only at that condition, Snell's law fails. Otherwise, no. Question number 11. Question number 12, possibly the last and numerical. Question number 12, solve numericals. Solve the numerical. To solve the numerical, you should know some formula. Formula V equal lambda F, and you can derive others. One, another mu equal x by y, or VA by VM, sin I by sin R, or sin R by sin I, according to the given condition. A number. First, let me do this. Find the refractive index of water if the speed of light in water and vacuum is 2.25 into 10 to the power 8 meter per second and 3 into 10 to the power 8 meter per second respectively. How to solve this? I think we can solve. Find the refractive index of water if the speed of light in water is this much and speed of light in vacuum is this much. See, for the sake of convenience, I will solve it. Solution. Here, this is the speed of light in, only hint. Vm equal 2.25 into 10 to the power 8 meter per second. Velocity of light in water, in both medium. Velocity of light in air or vacuum is 3 into 10 to the power 8 meter per second. Mu equal what? Refractive index equal. We know by the definition VA by VM. 3 into 10 to the power 8 meter per second upon 2.25 into 10 to the power 8 meter per second. Cancel. Now divide it 3 by 2.25. 3 divided by 2.25, 1.33. 1.33, nearly 1.33. That means if it is 1 meter, it should be 1.33 meter inside water. पानीभन्दा माथि यो सतहबाट 1 मिटर तल माछा देखिएको जस्तो देखियो भने actually it is 1.33 meter down. A fish is actually 1.33 meter deep inside the water, but it seems to be at 1 meter due to the refraction of light. 1.33 of water means you have to multiply the apparent depth by 1.33 to get the exact or real depth. Another question. See, if velocity of light, red light 10 to the power 8 meter per second. See, I write in short form and say wavelength equals say 0.00 8 meter. Find what? Frequency. Find frequency. Formula hint F equal V by lambda dot hertz. This by this divide, use a calculator, and something, the unit SI unit of frequency is hertz. Another, if V equal 3 into 10 to the power 8 meter per second, say frequency equal, you can write 99 or 96.6 megahertz. You know 96.6 megahertz frequency of Hetauda FM. It is Hetauda FM frequency. Or you can, it may be given velocity of light is 3 into 10 to the power 8 meters per second. F equal 96.6 megahertz. You have to write down 96.6 into 10 to the power 6 hertz and find wavelength. How to find? I'll just give you hint. Question number B and BC. Hint of this is lambda equal velocity by frequency. Velocity 3 into 10 to the power 8. Frequency given 96.6 into 10 to the power 6. You can cancel 10 square, 300 by 96.6 dot meter. You can write down something. 3 point something meter. C. 3D. Find, say I in this case. This is to find, say it is say 55 degree and say mu equal 1.75. You can easily find sin I by sin I mu. Hint. What is the hint of this? Hint. I have already solved such questions, but I equal angle of incidence. What? Angle of refraction is 90 minus 55, 35 degree. This is the angle of refraction, not this. And refractive index is given 1.75. We know mu equal sin I by sin I, because light is passing from rarer medium to a denser medium. It means when the light is bent towards the normal, it means rarer to denser. See. Denser to rarer away. If it is bent away, you should know that it is coming from denser to rarer. Rarer to denser, towards rarer to denser. Or 1.75 sin I unknown, sin I equal sin 35, or sin I equal 1.75 into sin 35 degree. Now I multiply it 1.75 into sin 35 degree. What is the exact value? 1.004. Here something is missing. It may not be 1.75. It is more than 1. So it may be wrong. Therefore 1.75 is changed into say 1.5. Please, you just convert it. 1.5 into sin 35. 1.5 into sin 35, 0.86. Therefore sin inverse 0.86. How much is this? shift sine 0.86 equal 59.31. 59.31 degree or 32 degree nearly fixed to. So sine can be written as sine inverse 0.86 fixed in degrees. D. Question number D. Question number E. Question number E. Find the refractive index. How to find? See, suppose it is say 60 degree. Suppose it is 40 degree. How to find the refractive index? This is I, this is I. How to find the refractive index? Since the light is going from a denser medium to a rarer medium, you have to know that light is going from denser medium to a rarer medium. How to find? Hint. I angle of incidence equal 90 degree minus 60 degree. This is the angle of incidence. What is the angle of refraction? 90. This one 90 degree minus 40 degrees. 50 degree is angle of refraction. Mu what? We know mu equal sine R by sine I. Sine 50 degree by sine 30 degree. Directly or by putting the value. See, sine 50 degree divide by sine 30 degree. 1.53. 1.53 nearly. It may be a glass, a special type of glass. See, angle of incidence 90 minus 60, angle of refraction 90 minus 40, 50. Mu equals sine R by sine I, because the light is going from denser medium to a rarer medium. Find mu, and you can easily find even R also. Okay? This angle of incidence. See, find angle of refraction. In this case, if the angle of incidence is, suppose this is say 45 degree, suppose it may be 65 degree, or to find the R. See, mu equal 1.5. How to find the angle of refraction? You can find the angle of refraction. See, hint. This is the angle of incidence. This is the angle of refraction. The angle of incidence is 90 minus 45. What? 90 minus 45? 45 degree. This angle is 45 degree. R equal what? Mu equal 1.5. We know mu equal what should it be? Rarer to denser.